Chapter 6 Summary. Network Layer in Communication. The network layer, or OSI Layer 3, provides service to allow end devices to exchange data across the network. To accomplish this end-to-end transport, the network layer uses four basic processes, which are addressing and end devices, encapsulation, routing, and encapsulating. Network layer protocols. The common network layers protocols include IPv4 and IPv6. IPv4 means IP version 4 and IPv6 means IP version 6. Legacy network layer protocols include Novel Internet Packet Exchange or IPX, Apple Talk, Connectionless Network Service or CLNS-DAS, DECnet. Limitations of IPv4: IP address depletion, internet routing table expansion, and lack of end-to-end connectivity. Introducing IPv6. It increase address space, it improves packet handling, eliminates the need for NAT, integrated security, 4 billion IPv4 addresses, 340 undecillion IPv6 addresses. Default gateway. Hosts must maintain their own local routing table to ensure that network layers packets are directed to the correct destination network. The local table of the host typically contains direct connection, local network route, and local default route. This is a route. A router is a computer. Cisco IOS. The Cisco IOS operating details vary on different internet working devices, depending on the device's purpose and feature set. However, Cisco IOS for routers provides the following. The first one is addressing, next is interfaces, routing, security, QoS, and QoS, and resources management. The summary. In this chapter we learned that the network layer or OSI layer 3 provides services to allow end devices to exchange data across the network. The second one is the network layer uses four basic processes, which is IP addressing for end devices, encapsulation, routing, and the encapsulation. The third one is the internet is largely based on IPv4, which is still the most widely used network protocol. The fourth one is an IPv4 packet contains the IP header and the payload. And the IPv6 simplified header offers several advantages over IPv4, including better routing efficiency, simplified extensions headers, and capability for per-flow processing. In addition to hierarchical addressing, the network layer is also responsible for routing. Hosts require a local routing table to ensure that packets are directly to the correct destination. The local default route is the route to the default gateway. The default gateway is the IP address of a router interface connected to the local network. And when a router such as the default gateway receives a packet, it examines the destination IP address to determine the destination network. The routing table above the router stores information about directly connected routes and remote routes to IP networks. If the network has an entry in its routing table for the destination network, the router forwards the packet. If no routing entry exists, the router may forward the packet to its own default route if one is configured, or it will drop the packet. Routing table entries can be configured manually on each router to provide a static routing, or the routers may communicate route information dynamically between each other using a routing protocol. For routers to be reachable, the router interface must be configured. In addition, default gateway for a switch. Typically, a workgroup switch that interconnects client computers is a layer 2 device. As such, a layer 2 switch does not require an IP address to function properly. However, if you wish to connect to the switch and administratively manage it over multiple networks, you will need to configure the SBI with an IPv4 address, subnet mask, and default gateway. The default gateway address is typically configured on all devices that wish to communicate beyond just their local network. In other words, so remotely access the switch from other network using SSH or Telnet, the switch must have an SBI with an IPv4 addresses, subnet mask, and default gateway address configured. If the switch is addressed from a host within the local network, then the default gateway IPv4 address is not required. In addition, the network layer, or OSI layer 3, provides service to allow end devices to exchange data across the network. To accomplish this end-to-end transport, the network layer uses 4 basic processes: the IP addressing for end devices, encapsulation, routing, and the encapsulation. The Internet is largely based on IPv4, which is still the most widely used network layer protocol. An IPv4 packet contains the IP header and the payload. However, IPv4 has a limited number of unique public IP addresses available. This led to the development of IP version 6 or IPv6. The IPv6 is simplified header offers several advantages over IPv4, including better routing efficiency, simplified extension header, and capability for per flow processing. Plus, IPv6 addresses are with 32 bits. This dramatically increased the number of available of IP address. Host required a local routing table to ensure that packets are directed to the correct destination network. The local table of a host typically contains the direct connections, the local network route, and the local default route. The local default route is the route to the default gateway. The default gateway is the IP address of a router interface connected to the local network. When a host needs to forward a packet to a destination address that is not on the same network as the host, the packet is sent to the default gateway for further processing. When a router, such as the default gateway, receives a packet, it examines the destination IP address to determine the destination network. The routing table of a router stores information about directly connected routes and remote routes to IP networks. If the router has an entry in its routing table for the destination network, then router forwards the packets. If no routing entry exists, the router may forward the packet to its own default route if one is configured, or it will drop the packet.